Hi, everyone. So this presentation is also sponsored by BioLase. So the purpose of using an erbium laser during a root canal is to improve the efficacy of your standard irrigants, to clean the smear layer debris out of the root canal, and to disinfect deeper into the dentin and into more of the lateral canals. So we, in this pilot study that I will be presenting, we followed the methods published in 2019 by in this study by Galler et al. We used extracted maxillary lateral incisors. They are all single-rooted, straight canal teeth. They have a very similar morphology. We have an N of 5 per group. They were all decoordinated, standardized to 12 millimeter length. To further standardize the model, we used a acrylic chamber that we created we created a standardized pulp chamber followed by a canal. The canal plus the extracted maxillary incisor. The canal length is about 18 millimeters. The incisor is placed in here, and all interfaces and the apex are sealed and waterproof, so the only place for the irrigant to go is really inside of the root canal. Oh, I forgot to mention, so we placed a laser tip at 3 different locations inside of the root canal. We're following the protocols set by the manufacturers for Photona and for BioLase. For Photona, we have laser tip in the pulp chamber. Then we have, for the WaterLase, we have a laser tip placed at 10 millimeters from the apex and at 5 millimeters from the apex. All groups were irrigated with methylene blue dye via needle irrigation. The treatments were standardized to 3 minutes in total, 3 cycles of 30 seconds of active irrigation, 30 seconds of rest. In the laser-activated irrigation groups, we're using the erbium YAG with a sweeps tip and their protocol, and with the WaterLase groups, we're using the 200 and 300 micron tip within the canal at the locations I previously mentioned. All of the teeth after irrigation were immediately removed, rinsed, dried, and then cross-sectioned at 5 millimeters away from the apex. We're measuring the depth penetration, so we're using methylene blue dye as an analog for how deep sodium hypochlorite would penetrate into the dentin. To have a visual, we're measuring from the canal walls, radiating outwards into the dentin, 20 measurements per sample. These are 3 images for each group. Each one is a separate tooth. Where we have needle irrigation sweeps 5 millimeters from the apex and 10 millimeters from the apex. See the results. The closer the tip is placed to your target, where the apical portion of the canal, the more effective it is at helping the irrigant penetrate deeper into the canals and into the dentin. And why does this happen? The erbium lasers work pretty much the same way. They activate water. They create a very quick and very fast rising pressure wave. You can see that the pressure wave is generated at the laser pulse, and then that laser pulse creates a large vapor bubble. That bubble collapses, creates another pressure wave, and then any rebound bubbles also collapse, create more pressure waves. This happens on a millisecond time scale, so you don't actually see these bubbles with the naked eye. We need a very fast camera for that. We also know that pressure dissipates very quickly over time. So you can see with every 5 millimeter depth away from the source, the pressure is reduced by about half. So at 10 millimeters away, it's a quarter of the original pressure. And the results are repeated in other published research independent studies. This one looked at debris scores, and they found the same. If you place the erbium YAG tip closer at the destination, at the target, you get much better, significantly improved debris removal. This study showed that the disinfection depth is the same with the two erbium lasers if the tip is placed a millimeter away from the dentin. So in conclusion, so basically the closer you are to the target, so the apical portion of the root canal, the more effective the laser-assisted root canal treatment is. And I have a neat video.